Hi everyone. Water is flowing steadily through a horizontal tube of non-uniform cross-section. If the pressure of water is 4 into 10 to the power 4 Newton per meter square at a point where cross-section is 0.02 meter square and velocity of flow is 2 meter per second, what is pressure at a point where cross-section reduces to 0.01 meter square? So look at the diagram here. In this question is given the what is the area of cross section in the first point? It is given the 0.02 meter square. And at that point, what is the velocity of flow? It is given the 2 meter per second. And the pressure at that region is given the 4 into 10 to the power 4 Pascal. And the next point is given the what is the pressure at a point where cross section area reduces to 0.01 meter square. So let's see this one. This is the 0.01 meter square small area. So this region, what is the pressure that we have to calculate? So let's write here, this is the P1 and this is the P2, and here the area is given the A2 and this is the area is given the A1, and the velocity at this point is taken as V1 and the velocity at this point you can consider as a V2. So first of all, we can use the equation of continuity. What is the equation of continuity? A1 V1 is equal to A2 V2. Okay, so what is the A1 here? 0.02 into V1, that is equal to 2, which is equal to A2 0.01 into V2. So we can calculate here the velocity V2 is equal to 0.02 into 2 divided by 0.01. Therefore V2 is equal to 4 meter per second. Now you apply the Bernoulli's principle. What is the Bernoulli's principle at the point one, number 1 and the point number 2? The pressure energy per unit volume. We can write here P1 plus kinetic energy per unit volume, that is equal to half into rho into V1 square, plus potential energy per unit volume. Here you can avoid the potential energy per unit volume because the pipe is almost horizontal, so height difference is not that much, so we can avoid the potential energy concept here, which must be equal to pressure energy per unit volume at the point number 2. So we can write here P2 plus kinetic energy per unit volume, that is equal to half into rho into V2 square. Here in the question it is asking for what is the pressure at a point where the cross section area reduces to 0.01 meter square. So in the second area pressure, that means you have to calculate here P2. So what we can write here, P2 is equal to P1 plus half into rho into V1 square minus half into rho into V2 square. So we can take the half into rho, take it outside. So V1 square minus V2 square. Substitute the value here, therefore P2 is equal to, what is the P1? P1 is given the 4 into 10 to the power 4 plus half into rho. What is the rho? The which liquid is flowing here? In this one you can see the water is the one is flowing there. So water density is equal to what? 10 to the power 3 into, what is the V1? V1 is given the 2. So 2 square 4 minus, what is V2? 4. 4 square what? 16. So it become what? Minus 12. Minus 12 divided by 2 minus 6. So what is the answer become? P2 is equal to 4 into 10 to the power 4 minus 6 into 10 to the power 3 can be written as P2 is equal to 4 into 10 to the power 4 minus 0.6 into 10 to the power 4. So you can answer, we can write here P2 is equal to 4 minus 0.6 into 10 to the power 4. Therefore answer is equal to 3.4 into 10 to the power 4 Pascal. So this is the final answer. So option B is the right answer. 3.4 into 10 to the power 4 Newton per meter square. Hope you understood this one. Thank you.